Astronomers thought they knew what the first galaxies looked like. Small, dim, chaotic. The cosmic equivalent of tiny villages just beginning to form. For decades, our understanding of the universe followed a simple story. The Big Bang occurred approximately 13.8 billion years ago. As the universe expanded and cooled, matter slowly gathered together. Clouds of gas formed the first stars. Those stars assembled into small galaxies. Over billions of years, those galaxies merged and grew into the majestic spirals and giant ellipticals we see today. It was a gradual process, a cosmic construction project unfolding over immense stretches of time. According to this picture, the earliest galaxies should have been tiny and primitive. The universe was young. Stars had only recently begun to shine. Heavy elements were scarce. Everything should have looked unfinished. To test these ideas, scientists built the most powerful space telescope ever created, the James Webb Space Telescope. Unlike previous observatories, Webb was designed to see infrared light. This is crucial because the expansion of the universe stretches ancient light into longer, redder wavelengths. The farther away an object is, the farther back in time we see it. In effect, Webb functions as a time machine. Its giant mirror collects faint light that began its journey more than 13 billion years ago. Webb allows us to witness the universe during its earliest chapters. Astronomers expected to find cosmic infants, young galaxies just beginning to assemble, small collections of stars struggling to grow. Instead, Webb revealed something unexpected, something that immediately caught the attention of astronomers around the world. Some of the galaxies appearing in Webb's earliest observations looked surprisingly bright, surprisingly large, and surprisingly mature. It was as if archaeologists had opened a tomb expecting crude stone tools and instead discovered a fully developed city. The universe seemed to be growing up faster than expected, and this was only the beginning. As Webb continued its observations, the surprises kept coming. Major surveys such as CEERS and JADES began cataloging galaxies from the first few hundred million years after the Big Bang. Some appeared extraordinarily bright. Some appeared remarkably massive. Others showed signs of organized structure that astronomers did not expect to see so early. These observations sparked intense debate. Were the galaxies truly as massive as they appeared? Had astronomers misunderstood how quickly stars could form? Or were the observations revealing something fundamentally new about cosmic evolution? One reason these discoveries attracted so much attention is because galaxy formation is not supposed to happen instantly. Stars need time to form. Galaxies need time to accumulate mass. Supernova explosions need time to create heavy elements such as oxygen, carbon, silicon, and iron. Yet some early galaxies appeared surprisingly enriched and surprisingly productive. Many were forming stars at astonishing rates, far faster than our own Milky Way forms stars today. Imagine expecting a small workshop and finding an enormous factory already operating at full capacity. That was the challenge facing astronomers. However, science did what science does best. Researchers investigated. Additional observations were collected. Measurements were refined. And some of the earliest estimates turned out to be too high. Several galaxies that initially appeared to rival the Milky Way in mass were later found to be less extreme than first reported. This was an important reminder that extraordinary discoveries require careful verification. But the mystery did not disappear. Even after revisions, many galaxies still appeared to have formed stars with remarkable efficiency. Some still seemed larger, brighter, and more developed than many theoretical models predicted. Rather than breaking cosmology, Webb was revealing areas where our understanding could be improved. The question shifted from, are these galaxies impossible? To, how did these galaxies become so impressive so quickly? That distinction matters, because the universe was not violating the laws of physics. Instead, it was teaching us that the earliest stages of galaxy formation may have been more dynamic than we imagined. And that realization opened the door to new possibilities. Today, astronomers are exploring several explanations. Perhaps the first generations of stars were unusually massive. Massive stars burn through their fuel quickly and can dramatically accelerate the growth of young galaxies. Perhaps early galaxies converted gas into stars more efficiently than modern galaxies do today. Another possibility involves supermassive black holes. Webb has discovered evidence that some black holes were growing rapidly during the universe's earliest epochs. These objects may have influenced the evolution of their host galaxies far sooner than expected. Researchers are also improving computer simulations. As observations become more precise, theorists can build better models of how matter behaved shortly after the Big Bang. This process is one of science's greatest strengths. When new evidence appears, theories are refined, predictions improve, and our understanding becomes more complete. The most exciting possibility is that we are witnessing the opening chapter of a much larger story. Webb is still early in its mission. It continues to collect data from the most distant reaches of space and time. Every year brings new observations, new discoveries, and new questions. The galaxies Webb has revealed are not signs that science has failed. They are signs that science is working. Nature is giving us fresh clues, and humanity is learning how to read them. Somewhere in the ancient light crossing billions of years of space, the universe is still telling its story. A story of stars, galaxies, black holes, and cosmic evolution on a scale almost impossible to comprehend. The galaxies that seemed too old, too perfect, and too early may ultimately help us understand how everything around us came to be, including our own galaxy, including our own sun, and ultimately ourselves. What do you think? Are these galaxies simply revealing gaps in our models? Or do you think Webb may uncover even bigger surprises in the years ahead? Share your thoughts in the comments below. If you enjoyed this journey through space, be sure to subscribe to Mellori Explores the Cosmos for more real space discoveries, cosmic mysteries, and stories from around our galaxy and beyond. Until next time, keep looking up.